Hello, everybody. This is Mr. Kusaj, and this is lesson 1-2 for Precalculus. The title is Analyzing Graphs of Functions. Now, don't get scared of that term, analyzing, because all it really means is the parts of a graph. Let's look at all the parts of a graph and all the things that it does. Okay? Well, not all of them, just a few important things. Okay. First of all, we already talked about domain and range. And the simplest way of explaining it, domain is really the x values, and range, we're talking about the y values. Okay? And some people memorize this as d comes before r, x comes before y. So domain is the x values, range is the y values. So suppose we had, before we get into the graph, do you remember these symbols in a number line? When we shade a number line, if it's a closed circle or an open circle, if you remember, then you know that closed circle means you include that point. Open circle means you're not equal to that point. You don't include that point. And of course, the arrow means you include everything that direction. Okay, do you remember that? It's kind of the same thing when we look at a graph. Let's look at this graph right here. Let me pull it up here a little bit. Look at this graph. What do you notice? Well, there's an arrow here. That means it goes in this direction forever. I notice that there's a shaded in circle here. That means it doesn't go forever in this direction. Okay, it includes this point, but it also starts at this point too and goes like this, right? It doesn't go down forever. Here, I noticed in the middle, an open circle. That means that point is not included in this graph, right? Okay, so first, let's talk about domain. When you look at this graph, and we are asked what is the domain, then what we want to know is what are the x values. So we're going to look from left to right, right? This is the x-axis. So if we look from left to right, here we go, left to right, notice that the x's, there's no graph here, no graph here, no graph here, right there. Our graph starts at -4. As far as the x is concerned, it starts at -4. And then notice that it keeps going, keeps going, keeps going, keeps going, keeps going, keeps going. It stops? No, it goes forever. It keeps going forever. So if we look from left to right, the graph goes from -4 onwards to the right forever. But looking carefully, it doesn't include x equals -3. There's a hole there, or an open circle. There's a hole there. So everything from -4 onwards except -3. So let's write that down. This is the domain for this graph. X is equal to and greater than -4, right? Everything except -3. X is not equal to -3. Or, more concisely, using the interval notation, we go from -4 to -3, and then we pick up and start again at -3 to infinity. We're never equal to -3. It doesn't include, right? Soft parentheses does not include -3, but we do include -4. That is the domain of this graph. Now let's look at the range of this graph. The range is when you look from bottom to top, right? The y-intercept. The range is the y values. So if we look at the graph from bottom to top, okay, here we go. Here's the bottom. Nothing, 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 nothing. Hey, it starts at -5. And then it goes on and on and on. Everything, there's a y there, there's a y there, there's a y there, there's a y there. and up and up and up and up and up and up forever. So it starts at -5, it starts at -5, and it goes up to infinity forever. Now, some of you might be thinking, oh yeah, except for y equals 2, there's nothing there. Yes, there is. There is a y value at 2. Let me pull it up. There is a y value at 2. Look closely. Now you're looking on the left here, but there is something here. That point right there, that's y equals 2. So there is a value at 2. That means there's a value for everything starting at -5 and going up. So we write it this way. From -5, including -5, and upwards forever. That is the range of this graph. So just by looking at a graph, you should be able to tell us, in English words, the domain, and hopefully you can interpret it and write it in interval notation. And you should be able to tell us the range and write it in interval notation. Okay, next thing we want to talk about for this lesson is intercepts. You can pause and take your time copying this. You don't have to make it beautiful. Just a quick sketch. What's important is that you notice that we're not talking about domain and range now. We're specifically talking about intercepts. Just like the English word intercept implies, where do we cross the axes? Right? So if you look here, here, and here, we cross the x-axes. So we call those x-intercepts. And if you look at this point, that's on the y-axis. So we're intercepting the y-axis. So that's the y-intercept. Now, whenever you cross an axis, there's a 0 involved. This is basic graphing. So the x-intercepts, we know what the y is on the x-intercepts. It's always 0. We just don't know what the x is. That's our job to find out. So that would be the x-intercept, right? Y is equal to 0 here, it's equal to 0 here, it's equal to 0 here. And then the other way, for the y-intercept, I don't know where this is on the y-axis, but I know x equals 0 here. So I know x equals 0, I just don't know y. Okay? So now our job is to find the intercepts. I'm going to give you a graph, and you find the intercept. As the year goes on, you're going to see zeros, the term zeros being used interchangeably with x-intercepts. So we can call these the x-intercepts of the graph, or we can call them the zeros of the graph. It means exactly the same thing. Okay? So find the intercepts, find the zeros, means the same thing. All right. First, let's work on the y-intercept. Find the y-intercept. What that means is 0 something. 0 what? Find this number that goes here. Right? So if we let x equals 0, we can solve. So here is your graph. Now, if we look at it, maybe you can guess, right? Maybe you can guess, especially if you had the marks here, you can guess pretty close, what is the y-intercept. I'm thinking 1 or 2, right? I'm thinking 1 or 2. But since we have the function in algebraic form, we can work on this and find out what the exact value of y is here. How do you do that? Well, simply let x equal 0. Just plug in 0. Let x equal 0 and solve it like this, right? So we're really looking for f of 0. You put in the 0 there, right? I'm doing this quick. You solve it, and you get 4 over 3, which equals 1 1/3. There you go. I got it. This y-intercept is at 1 1/3 up. We already know x is 0. So the y-intercept is at 0, 1 1/3. That point is at 0, 1 1/3. Okay, I found the y-intercept. Now you do one. See how far you can get with this. Do you work on the right here? Find the y-intercept of this function. Here's the picture, the graph. It's right there. I don't know, it looks like 2 or something. So here is your function in algebraic form. So how do you find the y-intercept? Do what I did up there. Okay? Try something. Just see how far you go. Just go step by step, just like I did it here, and see if you can do it. If you can't do it, or if you don't understand something here, just put a little question mark, circle it, highlight it, whatever, and then next time I see you, raise your hand and ask me about it. So now, that's the y-intercept. Let's look at the x-intercept. How do you get the x-intercept? All right. Find the x-intercept, which is another way of saying find the zeros. Okay, so remember, x-intercept, we already know y is 0, we just don't know what x is. So here's what we do. We let y equal 0, and then solve for x, right? We know y is 0. So here's our example. Let me pull it up. So I noticed that there's going to be 2. There's 2 x-intercepts. It looks like, I don't know, maybe -2 and 3 maybe, looking at this graph. So the way we find out for certain the exact values is by letting y equal 0. And remember, fx means y. Put a 0 here, and then solve for x, like this. Okay, so how do you solve an equation with an x squared? If you remember, that's a quadratic, so we factor. I factored it for you. You should know how to. And then this is equal to 0. This is equal to 0. Solve both of them separately, and you get this. So x equals 2.5, and x equals -3. So I guess, going back to the graph, this is -3, and this is 2.5. -3, 0, 2.5, 0. Remember, we know what y is, we just don't know what x is. So let's write it down. The x-intercepts are 0, -3, 0, 2.5. Okay? Now, you try one. Here's the graph. Oh, look, there's only one x-intercept. And it looks like it's going to be -1. Maybe it's -1.5. I don't know. So how do you do this? Look at the above example and work it out right here. Do the best you can. Try something. Don't leave it blank. All right? This is the end of part 1. And tune in, I guess, tomorrow for part 2. Certainly before I see you next time, you should have both parts. Okay, 14 minutes, not bad. All right, good night.